So we're going to look a little bit at domain and range, and we're really going to look specifically right now at three types of functions. We'll look at polynomials, we'll look at rational functions, and we'll look at radical functions. So let's first, I guess, look at a couple examples of polynomial functions. And you've probably seen these before. They look a little bit like y equals x cubed minus 2x squared plus 1, or y equals x plus 5, something of that nature. Maybe y equals x squared minus 6x plus 5. Now, when we talk about domain, we first need to understand what they really mean when they talk about domain. So here's what a graph of, let's say, a quadratic function looks like. Right? Something nice and simple like that. Now, when we talk about domain, we're really trying to talk about all the values of x that are acceptable. In other words, all the values of x that you can actually plug in as input values into an equation and get a corresponding value out. Now look at this graph. Does it look like there's any value of x, even if you look at this equation, that we cannot plug in for x? And the answer is no. I could plug in negative numbers, I could plug in positive numbers, I could plug in fractions, decimals, radicals, it doesn't matter. And I'm always going to be able to square those numbers and get an answer out. And for that reason, the domain of polynomials is really always going to be all real numbers. So let's just make a note of that real quick. The domain of polynomials is always going to be all real numbers. Okay, so that's the easy case. Now let's take a little bit better and longer look at things like rational functions. Okay, here we have two different functions, right? We call them rational functions because they really are fractions, they're ratios. And as you know, when we have fractions, we have an issue because we can never do what? We can never divide by 0. So that being said, what we really have to watch out for here is where would the denominator equal 0, right? That's not a good thing. So that's really our aim, because as we said before, the domain should be all the values of x that I could actually plug into an equation, get an output for, right? Well, in this first example, there is one value of x that I can't plug in, and that would be -4, because if I do, I'd get -5 on top, and I'd get 0 on the bottom, which obviously is undefined. So for that reason, the domain of this example would be all real numbers, but x could not equal -4. Now we've been discussing interval notation, so how would I write that as an interval? Well, really you have to say that every number is possible except -4. So you can go from -infinity to -4, and then from -4 to infinity. Now, let's take a look at this second example. Right? In this case, when we set x squared minus 9 equal to 0, we actually find that there's two values of x that you can't have. One is x can't be 3, and the other one is it can't be -3, right? So your domain here would really be all reals except those numbers. How do I write that as an interval? Well, again, let's think of a number line, right? Okay, here's your number line, here's -3, here's 3. Those are the two values that you cannot have, right? So what we have to do is we have to make sure people understand that those values are not acceptable in the domain. So all the other values are. If I plug in 1/2 or 0 or 2, I'll get an answer. So how do we express our intervals here? Well, -infinity to -3, right? I can't include -3. Then I could go -3 to 3. Again, I can't include -3 or 3. And then finally I could say 3 to infinity. So that's my domain. The domain of all the values, right, that I could actually plug into this equation and get an answer out. Okay, now let's talk about radical functions. So with fractions we had a concern because we can never get 0 in the bottom. With the square root of something, for instance, there's definitely a problem because square roots are not defined for all numbers. So for instance, I could do the square root of 8, the square root of 1/2, square root of 0.6, the square root of pi, it doesn't matter. But if you notice, I'm shying away from one group of numbers, and that would be negative numbers, right? I cannot take the square root of a negative number. It's impossible. So since that's not possible, what we have to do is we have to think about when the radicand, that would be that right there, right? When is that greater than or equal to 0? That's really the question. So let's look at a few examples. Okay, in our first example, we see here that the radicand, which is right there, right, is x minus 6. Well, what does that mean? That means x minus 6 has to be greater than or equal to 0, because if it's not, we can't take the square root of that. So what I could do here is just solve this real quick and find out that x must be greater than or equal to 6, which means, again, in the grand scheme of things, here is 6. We can only have numbers that are bigger than or equal to 6. So how do I express that as an interval? Right, well, all I would do here is say, well, you can include 6, and you can go anything bigger than 6. So that would be your domain, 6 to infinity, including 6. Now, when we look at this second example, we know that, again, we have 2 minus 7x as my radicand. Let's do that. Okay, so what do I have to do? Well, I have to, again, set that equal to, or greater than or equal to 0. Now, when I solve this, negative 7x is greater than or equal to negative 2. Watch out for switching the sign here. X is going to have to be less than or equal to 2/7. So basically, again, that's my domain, right? How do I express that? Well, I can say that everything less than or equal to 2/7 would be negative infinity up until and including 2/7. There's your domain. Okay, so what we want to really be able to do is we always want to be able to support some of our conclusions. And one of the ways we can do that with domain is we can talk about looking at the graph to support it. So this first graph is the graph of a rational function. I'm not going to tell you which function, but I want to really just talk about how you can identify the domain just by looking at a picture. So if we just think about x values, right, in other words, thinking about going this way, right, looking at a graph this way, we can see that this graph really carries on every single x value except for one of them, and that's 1, right? We have a situation here where this number right here, 1, is somehow a problem, and that's because we see an asymptote, what we call vertical asymptote. And an asymptote, remember, is a line that a graph can approach but never actually touch. So because of that, that limits our domain. So our domain is going to have to be basically everything but 1. So that would be negative infinity up until 1, and then 1 to infinity. And so that's something we just have to look for on a graph. Is there anything that we don't see as part of the graph? And in this case, it would be 1. On the second graph, we can see that the graph really is just taking on its shape really from about 2 over, right, in this area, negative 2 over. So because of that, our domain can only be negative 2 to infinity, right? And that's it. Okay, so to finish this whole discussion up, what we'll do now is just talk about, again, reading graphs using domain and range and really putting it all together. Okay, so when we look at a graph, again, we're looking for domain. Really, we're looking this direction, right? We're trying to see how much of the graph spans this horizontal direction. And when we think about range, it's the first time we're really talking about that, range really consists of all the output values or the y values, so we're going to be looking vertically. How much of the graph is spanned vertically? So let's look at this first example. We look left to right, and we can see that it kind of starts here, looks like at negative 5, and it doesn't go any further than 3. And since that's the case, that's our domain. So our domain for this problem would just be negative 5 to 3. Now the question is, do I use brackets or parentheses? Well, if you look over here on the left, right, I'm using an open circle, which means it's not included, right? But if you look over here at 3, I'm using a closed circle, which means it is included. So our domain here would be parentheses negative 5 to 3 bracket. Now what about the range, right? Well, the range, again, we're looking vertically, right? So we're looking this way now, trying to see, hey, how low, how high is this graph? So it looks like the lowest y value that we see, right about here, is negative 3, right? And that goes all the way up until we get to about 2. And again, open circle at negative 3 on the y axis, right? and it makes its way up to 2, and it's including 2. So very similar parentheses and bracket notation there. Now for our second example, right, let's look at this graph here. If you notice these arrows, those are kind of a big deal, because really what they mean is we have to use our imagination a little bit, but these ends of the graphs are going off the screen. So since that's the case, we can't really pin this down to just kind of being from here to there. It's really going off in both directions. So because of that, the domain here is really all real numbers. When we look at the range, it's really the same thing, because if this arrow continues to go down that way and this arrow continues to go up that way, we're really covering all the y values. So again, the range here would be all real numbers. Okay, so now I think the important thing here is we got to try this on our own. So you try these 3 problems. On the left-hand side here, we're just going to find the domain of these 2 functions, try and use the rules we talked about. And on the right-hand side here for number 3, we'll give you a graph. We're going to try and find the domain and the range. So I would pause the video, and then as soon as you unpause it, we'll go to the next screen and we'll show you the answers. Okay, so if you're ready, then let's go to the next page. And here are your answers. For our first problem, we had a fraction, so we couldn't have the denominator be 0, so we had to find out when that happens. And when we do that, we have to factor the bottom. We find out that x cannot be 4 or 3, and then we have our answer here as an interval. For the second problem, it was a radical, and we had said before that the radicand, the piece under the radical, has to be greater than or equal to 0. So we went ahead and set that greater than or equal to 0, solved it, watch out for the dividing by a negative, and so we found out that x had to be less than or equal to 8 over 7. Maybe the trickiest problem was the graph, and so what we did here was we actually gave you 2 pieces, and the first domain would be the first piece. So if we went by 2's on the graph, we'd be going from -6 to 0. You can include -6 because of that closed circle, and you don't include 0 because of that open circle. Then it jumps a little bit, and we go from 4 to 8. Again, not including 4 at the open circle, but including 8. And these are just x values, right? So this domain, really, we're talking about x values. Now we go to the range, and we're looking at the y values. And it goes from -8 to 8, even though it jumps, because where the one piece stops, right, where this piece stops right here, in that area, right, it keeps going over here. So it kind of takes up those values for you. So you really, when you look at the vertical stretch of this, right, and you look at the span of it, it really does go from -8 to 8. Closed circle down here, open circle up there. So hopefully this was helpful for you. Go back to those answers real quick. If you have any questions, you could always email me. At this address. And I'd be happy to help more.